Hello and welcome to the fifth and final day of boot camp. Today we are going to go ahead and look at some application problems. They are going to be more about our quadratic equations. Remember, we're having a test on both Chapter 4 and Chapter 5. That's going to be about quadratics, which is our parabolas, as well as our polynomials. Yesterday we looked at some problems with roller coasters, and those are graphs of polynomials. Today I'm going to go ahead and look at, we're not going to be graphing these so much, a little bit of estimates really, but just sketches really for the most part. And we're actually really just going to focus on the critical thinking here because at this point you guys actually do know how to do all the math that's required to get these answers. So first example that we're going to look at is going to be this one. While playing basketball this weekend, Frank shoots an air ball. Happens to me all the time. The height in feet of the ball is given by h equals negative 16t squared plus 32t plus 8. What you need to do right now before we get any farther on this problem, I'd like to take some time and go ahead and sketch what you think that graph will look like of the ball's path. And remember, we're looking at our function of h equals negative 16t squared plus 32t plus 8. So I'll give some time to copy that down. And while you're copying that down, I'd like to go ahead and, like I said, try to sketch that graph. One thing that you do know from here, when we make that sketch, is our y-intercept. It's going to happen at positive 8. Biggest thing I'm concerned with on this is that we're looking at the relationship between height and time. So I want to make sure that you guys are okay with the idea that time is what's happening on the x-axis and height is how high that ball is going to go. So if you look at it in this case, given by the equation, we're at positive 8, we're going to shoot the ball into the air, we're going to miss everything, and at some point it's going to hit the ground. I don't know how long that's going to take yet. I have no clue. I do know some things about parabolas, though. And a reminder of our maximum height. Remember, this parabola goes down. Our maximum height will be at the vertex. That'll come into play a little bit later on this problem. But the first part I want to look at is how long will it take for that ball to hit the ground when I shoot this air ball. So that's really questioning right now. I want to find x, which is my time, when the height of the ball is what? Hopefully you're thinking, I want to find out the time when the height of the ball is 0. That's when the ball is going to hit the ground. See if this doesn't make sense. I want to figure out the height of the time I would like to solve this quadratic equation for t when my height is 0. Mr. Wood, that's just a quadratic equation. Negative 16t squared plus 32t plus 8 equals 0. I know how to solve that. It's by factoring or by the quadratic formula. Yes, I know. It's almost like we've been practicing all week just to get to this problem. All right, next up, we're going to have to go ahead and solve this using the quadratic formula. I will tell you right now, this problem is not factorable. So we're going to take this, I'm going to move this to the next page. I'm going to solve it using the quadratic formula. We do know that A is equal to negative 16 here, B is equal to 32, and C is equal to 8. Substituting in quadratic formula once again, if you don't have it memorized, this x equals negative b plus or minus square root b squared minus 4ac over 2a. I'm going to substitute and simplify for this. Like I said, it's not factorable. If you'd like, and I'm going to do it on this problem right here, I'm going to go ahead and reduce. I'm going to remove a factor here. I'm going to take out a common factor of, let's see, 8. If I take out a factor of negative 8, that will leave me with 2t squared plus 16t plus 4. Again, you guys can try and factor that if you'd like. Oops, made a mistake here. We've got negative 16 and negative 4. I can't reduce in my head. There we go. At this point, oh, still, that's 2 errors in this problem. Strike 2 for me. Negative 2t squared, that's going to be negative 4t, and that's going to be a negative 1. I like those numbers. They're a lot smaller, a lot easier to deal with. Still not factorable. So, at this point, we're going to go ahead and solve these in quadratic formula. Again, you can try to factor that. Negative 2, negative 4, and you see what I'm talking about. 2t, 2t, neither one's factorable. So, quadratic formula is the way to go on this problem. A is going to equal 2. I'll write it right here for you. A equals 2, B equals negative 4, and C equals negative 1. Again, you're welcome to use those big numbers. I just choose not to. So x is going to equal, that's a negative negative 4, plus or minus the square root of b squared, which is negative 4 squared minus 4 times 2 times negative 1. That's all over 2 times 2. Go ahead and simplify this. X is going to equal 4 plus or minus the square root. And negative 4 squared is 16. And then we've got 16. That is a negative 4 times a positive 2, negative 8. Negative 8 times negative 1 is positive 8. And that's going to be over 2 times 2, which is 4. At this point, we need to finish this. That's going to be x equals 4 plus or minus the square root of 24 over 4. Simplify that radical, it's square root of 24. And that comes down to be, 12 and 2, 6 and 2, and then 2 and 3. Hopefully you guys agree with me, that's going to be 2 root 6. So x is going to be 4 plus or minus 2 square root of 6 over 4. And we will go ahead and take care of this. Did I do anything wrong here? I'm making sure that I got it. Negative 16, positive 32, positive 8, we're good. 16 plus 8, 24, good. All right. Reduce this, take out a factor of 2. Next gives us, I could have taken out a factor of 2. That's going to give us 2 plus or minus the square root of 6 over 2. 2 goes into 4 twice, 2 goes into 4 twice, 2 goes into 2 once. That was my common factor. So now here's my solution to this problem. X equals 2 plus or minus the square root of 6 over 2. That's quadratic formula. Good. I know how to do that, Mr. Wood. What were we doing in this problem again? Why were we doing this? Well, the reason that we're doing this is to figure out how long it takes the ball to hit the ground. I have 2 solutions on this problem. They are x equals 2 plus the square root of 6 divided by 2. The other one is x equals 2 minus the square root of 6 divided by 2. At this point, you'll use your calculator, get an estimate. The square root of 6, just from your calculator, is approximately, we'll call that 2.5. So that's the number I'm going to use at this point. The reason I'm going to go ahead and use decimals, usually I'll leave it in simplified radical form. That's usually good enough up here. But now this problem is asking me for how long it takes. So I need to get a number here. So what I'm going to do, I'm going to plug in 2.5 and I'm going to get my estimate here. 2.5 and 2.5. At this point, I'm going to tell you that I'm only going to do one part of this problem. I'm talking about shooting an air ball with a basketball. I know in my head that 2 minus 2.5 up top, that's a negative answer. That means that this root or this solution or this part will be negative. Because that part's going to be negative, I'm not concerned with the answer for this problem. I can't shoot the ball in the air on a negative amount of time. However, I can shoot the ball 2 plus 2.5. Remember, our x value is time. It's a time in seconds. So that gives me 4.5 divided by 2, which comes out to be about 2.25. So I'm not concerned with that other root there. Again, it's negative. This problem's asking me how long the ball was in the air. My quadratic equation wasn't factorable. I reduced it at the beginning because I took out that negative a. I didn't like that. I tried to factor it. It wasn't factorable. I went to the quadratic formula, solved it, simplified, and then got my answer. I only did one solution to this because I'm only concerned with that one solution. So I did all that to do this. How long will it take the ball to strike the ground? Well, according to that function and my model, it's going to take me about 2.25 seconds. That's how long that ball is going to be in the air. Next part. What time is the ball at its maximum height? That's pretty easy, in my opinion. I think this part and the third part of this problem are easier than that part I just did. Certainly it's less work. Time the ball is at its maximum height. At this point, we know maximums occur at the vertex of the parabola. So I can find my x value. X value is time in this case. If my x value is time, that's all it's asking me. What time is the ball at its maximum height? This is saying, what is the x value of the vertex of this parabola? All I want you to do is find the vertex. X equals negative b over 2a. That's negative 32 over 2 times negative 16. That is negative 32 over 2 times negative 16, which is negative 32. Negative 32 over negative 32 is 1. So this ball is going to reach its maximum height in 1 second. That's 1 second right there. That was kind of easy. Yep. It's supposed to be. If you understand what we're talking about, if you see how this graph relates to us actually shooting a basketball, and realize it's going back to what we've always talked about, vertexes, most important planets are parabolas. That's a vertex, and its roots, and its y-intercept. If you know those things, you can answer a lot of these questions. Notice, what's the maximum height of the ball? That should be pretty straightforward. Maximum height is going to be the y value at the vertex. Well, I know this function is modeled by h equals negative 16t squared plus 32t plus 8. I want to know what the height is, that's h, when x is at its max. So what is the height at the vertex? My height will be, let's see, 1 squared is just 1, plus negative 16, plus 32, plus 8. My height will be negative 16 plus 40, which comes out to be 24 feet. That's a pretty good sized air ball on my part. So I shot the basketball. When it was about a second in the air, it got to a maximum height of 24 feet. It hit the ground in 2.25 seconds. That's what happened. And that's all we need to know there. There's the bottom part for those of you guys who just asked me to scroll back up. All right, for those of you guys who listen to the notes, here's today's secret word. I want to know What is the name of the guy that was in this problem? I said it was me the whole time. Actually, today's secret word is Frank. That's the guy's name that was in this problem. That's what you need to have on your paper. All right, next problem we're going to look at here. You've seen a similar problem like this. We've talked about it before. In fact, we've dealt with volumes. We've dealt with more difficult problems than this. We've got a steel frame. Your company is going to make frames as part of a new product they are launching. The frame's going to be cut out of a piece of steel, and to keep the weight down, the final area should be 28 centimeters. That's talking about the area of the frame. It's talking about this right here. That is going to be 28 centimeters. The inside of the frame, whatever you're going to put in it, is going to be, it has the dimensions of 6 centimeters by 11 centimeters. That means this, the inside, is going to be 6 by 11. And if that's what we're going to have happen, the question is, what's going to be the width? And that's what we're asking. What's going to be the width? So I'll give you guys some time to go ahead and copy that down. In fact, you might want to go ahead and pause the video at this point to go ahead and get your sketch down and get the information down. I'm going to be going ahead and moving forward with the rest of this problem. But like I said, you should probably pause the video to catch up because there's a lot of words here that you need to get down. Okay, hopefully you paused the video. Now we're going to go ahead and move on with the rest of the problem. First part, what is the length of the frame? The length of the frame. That's asking me, how long is it from here to here? What is the length of that frame? Well, we've seen a problem similar to this before. The distance from here to here is 11. The distance from here to here is x, and the distance from here to here is x. So the overall distance of my length, hopefully this makes sense, will be 11 plus x, which is really 11 plus 2x. So what is the length of the frame? 11 plus 2x. Next part of the problem. What is the width of the frame? Hopefully you guys see the patterning here. It's going to be very similar to that previous problem. We're now talking about width. That distance is 6. The distance from here to here is x. I'm sorry, that's in green. It's kind of hard to see. That distance is also x. So the overall distance on the outside, which we're looking for width, will be 6 plus x, which is 6 plus 2x. So what is the width of the frame? 6 plus 2x. All right, next part. Write an expression for the area of the steel frame. The area of the steel frame should be length times width. That's the area of that whole frame. So area of that steel frame is going to be length times width, which is going to be, so I'm going to write area equals length times width, which is going to equal length, which is 11 plus 2x, times 6 plus 2x. But some of you guys, hopefully right now, are not really okay with what I've written, because that area is everything, length times width here. That would be the whole part, area. The catch is, I only want the area of the steel frame. And that's this area here. And right now, I have the area of all of the outside. That's length times width. So if I want the area of the red part, which is 28, hopefully it makes sense to you that I'm going to take my big length times width, which is the outside, and then I'm going to subtract out my area on the inside. And hopefully you'll see that if I have the area of this black rectangle and I subtract out the area of the green rectangle, then what I'm left with is the area of the frame, which is in the red there, which is 28. So the area of what's in the red, which we said is 28, is going to equal the big length times the big width minus the area of the green, which is length times width. I can put that as 6 times 11 for you, because you'll see that as length times width. That's the area of the green. So now that is an expression. That's an expression for the area of that steel frame. And what does the area of the steel frame need to be equal to? Well, that needs to be equal to 28, Mr. Wood. Yep. So that's what we're going to write. We've got 11 plus 2x times 6 plus 2x. That's length times width of the big black rectangle. We're subtracting out the area of the green rectangle, and we're going to set it equal to the area of the steel frame, and that's what we want. Make that 28 a little bit better for you. Mr. Wood, I think I know how to solve this. Really? How? I'm going to multiply those two terms together. I'm going to combine like terms. I'm going to set one side equal to 0. I'm going to solve either by factoring or using the quadratic formula. Exactly. That's exactly what you're going to do. So do it. Okay. Double distribution is the way that I'm going to go here. 66 plus 22x plus 12x plus 4x squared minus 66 equals 28. That's an 8. Let's see, combine like terms. Oh, I got this. 66 minus 66. We're done with that. Combining like terms and putting it in standard form. 4x squared plus 24x equals 28. This is looking familiar. Minus 28 from both sides. 4x squared plus 24x minus 28 equals 0. I know how to solve that. I notice there's a common factor of 4. I'm going to go divide out a common factor of 4. 4 goes into 4, 4 goes into 24, and 4 goes into 28. 4 goes into 0. So x squared plus 12x minus 14 equals 0. Oops. Whew. I almost made another mistake there. How about x squared plus 6x minus 7 equals 0? That's much better. All right. Negative 7, positive 6. By the way, we're going to try to factor this. Two numbers that multiply together to give me negative 7 and add together to give me positive 6. Hopefully you're thinking that is positive 7 and negative 1. That works. Like this problem. We've got x plus 7 as a factor and x minus 1 as a factor. We set it equal to 0. We're finding the roots. Yes, in this problem, it's really not talking about a parabola, although its graph would be like that. We're talking about length and width of a frame here. So let's look at our zero product property. We get a root here that's x equal to 1. We get a root here that x equals negative 7. Hopefully you're thinking right now, Mr. Wood, yeah, that's not going to happen. Side length of negative 7, I can't have anything that's negative 7 inches long. That's not going to work for me. So that must mean x needs to equal 1, or what should the width of the metal be? What the question was asking. That is going to be 1 centimeter, not inches, centimeter. We were in centimeters on this problem. Okay. For those of you guys who are asking to scroll back down the board, there's the rest of the work down there. Again, at this point, you guys should be pretty darn good at factoring. Hopefully that makes sense. And if it doesn't, I'm kind of in trouble at this point. All right, believe it or not, we only got one problem left. And believe it or not, we're ready to roll. Okay. Let's go. John's hitting baseballs. What's the next problem? Let's see. John's hitting baseballs. When he tosses the ball into the air, his hand is 5 feet above the ground. Hits the ball when it falls back to a height of 4 feet. The height of the ball is given by ht equals 5 plus 25t minus 16t squared, where t is in seconds. Okay, this is very similar to that first problem we did. Let's go ahead and take a look at this one. Before we go on, I would say go ahead and sketch this. We want to know how much time will pass before John hits the ball. That's one part, and the second part is what is the maximum height the ball attains. So hopefully right now you already know the maximum height is going to happen at the vertex. And a quick sketch, I'm not asking you to graph the whole thing, quick sketch. Let's see. He tosses the ball in the air. Once again, we have time on our x-axis, and we have height on our y-axis. Tosses the ball in the air. His hand is 5 feet above ground. Means he's going to toss the ball in the air. And he's just tossing the ball in the air, and then he's going to step and swing. So what's going to happen? The ball is going to go up the height. It's going to come back down. And at force, at a height of 4 feet, that height of 4 feet is when he's going to swing the bat, and then he's going to hit the ball, and it's going to do something. We're not really concerned with what happens after he hits the ball. We're really concerned about this first part of the parabola, which is him standing there, tossing the ball up in the air, and then swinging the bat. So hopefully, you'll agree with me that our height is not going to be really too high, and this time is going to be pretty brief because he's just going to toss it up, it's going to come down, he's going to swing and hit at it. So how much time will pass before John hits the ball? Well, as we talked about already, John's going to hit the ball when it's at a height of 4 feet off the ground. He's not going to hit the ball in this problem off the ground. He's going to hit it when it's 4 feet in the air still. Mr. Wood, we haven't done something like this before. Well, let's put it into context. I'm trying to figure out what the time is when my height is 4. I have an equation that models time and height. My equation says height is 5 plus 25t minus 16t squared. That's from the problem. Well, this problem is asking me what time is when the height's 4. Isn't that just saying when this height is 4, how long did it take? Yes, that's exactly what it's saying. In fact, that's just another quadratic equation that we have to solve. I'll do it on the next page. Again, we set height equal to 4 because that's when I'm hitting the ball, and the question asks me how long it will take, that's the t, when the height is 4. So we've got to solve that. 4 equals 5 plus 25t minus 16t squared. Gee, Mr. Wood, this looks awfully much like a quadratic equation. Let's see. That means I should get one side equal to 0 and try and factor it. And it means if I can't factor it, then I should use quadratic formula. It's kind of like what we've been doing all week. Yes, I know. It's supposed to. I don't want to say it, but I think I'm starting to understand this. Good. You're supposed to. All right, here we go. Let's solve this bad boy. I think what I'm going to do first, I'll go ahead and minus 4 from both sides. That's going to give me, and I'm going to put it in center form when I do that. So that's going to give me negative 16t squared plus 25t plus 1. My t's look a little bit like pluses, so I'll make them a little bit bigger. Negative 16t squared plus 25t plus 1, I'll tell you right now, it doesn't factor. So we're going to get right back in, we're going to get into quadratic formula here. A equals negative 16, B equals 25, and C equals 1. And X is going to equal to negative B plus or minus the square root B squared minus 4AC over 2A. X is going to equal negative 25 plus or minus the square root of 25 squared minus 4 times negative 16 times 1 over 2 times negative 16. That's a beastly quadratic equation. It is just a number crunch in your calculator. You guys know how to do that. It's going to give you x equals negative 25 plus or minus the square root. I'm going to tell you that 25 squared plus 4 times 16 will come out to be 689. Like I said, it's a calculator crunch. I'm not going to worry about that. Finish this problem up. I don't really, in this problem, we're talking about how long. Once again, we want to get a decimal estimate. I don't care about answers being in simplified radical. I want an actual estimate about how long here. So you can just plug in the square root of 689 in your calculator. When you plug in the square root of 689, I'm going to tell you that the square root of 689 comes out to be about 26.25 if you just round it. So you can test that in your calc, make sure you're okay with how I found that. And we've got x equals negative 25 plus or minus 26.25. And that's all going to be over negative 32. Okay, we've got two solutions here. And again, I'm going to use the wiggles because we're approximately, because we've got a decimal approximation at this point. My two solutions, x is going to be approximately negative 25, I can write negative 25, negative 25 minus 26.25 over negative 32. That's one solution. The other solution is going to be x equals negative 25 plus 26.25 over negative 32. And you're welcome to crunch both of these numbers, but I'll tell you I'm going to use critical thinking here, and I'm only going to crunch one of those numbers. Because once again, my function is talking about the height when x is 4. There's two locations on this parabola that x is going to be 4. One is less than 0, which does not make sense in the context of this problem, and the other one is the one I'm looking for, or the positive root, or the positive, not root, that's the wrong word, the positive solution here is what I'm looking for. I'll have a positive and a negative. So the positive solution is the one I'm looking for here. One of these gives me a positive, the other one gives me a negative. the bottom one, negative 25 plus 26, that numerator will be positive. That denominator is going to be negative. So that means my answer will be negative. Means I don't want to do that one. I want the answer that's going to give me a positive solution. In this case, negative 25 minus 26.25, that's going to give me an answer of, what, negative 51.25 divided by negative 32. Notice that that is a negative divided by a negative. A negative divided by a negative is positive. It's going to give me a positive solution there. If you plug that in your calc, you're going to get something that's close to about 1.6. That's what I want. You guys are welcome to calculate that bottom one. I don't care. I'm not concerned about it in the context of this problem. If I was graphing this thing and finding the roots, then I'd need to find it. But in this problem, I'm not asking about that. So, how much time will pass when John hits the ball? How much time will pass? That's this thing right there. It's going to be about 1.6 seconds before he hits the ball. Second part, maximum height the ball attains. All at this point, we should note the maximum height is going to happen at the vertex. In this case, since the parabola opens down, it's going to happen. It's going to be maximum value. So really, as long as we find the y value or the height at the vertex, we've got this problem. So our function, h of t, in standard form, negative 16t squared plus 25t plus 5. What happens at the vertex, or where is the vertex? Should be thinking. That's going to be x equals negative b over 2a. That's negative 25 over 2 times negative 16. I will tell you that comes out as a decimal. Negative divided by a negative is positive. And that decimal comes out to be about 0.78. That's fine. That means about 3/4 of a second is when that's going to meet its maximum height. But I'm not concerned with time. I'm concerned with height. That's my y value. So I need to know what the height's going to be when my time is 0.78 of a second. Now we've got a calculator crunch. H of 0.78, calculator crunch. We're going to approximate that. And I'll let you guys do that in your calc on your own. I got something about 14.77 feet. Hopefully you guys get the same thing. I would encourage you to make sure your calculator can crunch that. And you're comfortable with it. We already did some calculator crunches with our roller coaster problems. 14.77, I'm fine if you just say, hey, that maximum height was about 15 feet. Round it up. Okay? Context, connections put together. Let's start with the ball, toss it up in the air 5 feet. At 5 feet up, it's in the air for about 3/4 of a second, 0.78 of a second. It reaches a maximum height of about 15 feet there. Then the ball is going to come back down. And when it hits the height of 4, I'm going to go ahead and hit that ball with my bat, and then something else is going to happen. I'm probably going to hit it out of the park, or if it's me, I'll probably just dribble it right at my feet. So that's what we're looking at. Hopefully you see the connections, quadratic formula, applications of vertex, basically realizing that these word problems are just asking you information that you already know. Okay? And hopefully you have your word of the day. That's it for examples today in class, or tomorrow in class, I should say. We're going to go ahead and we'll do another kind of integrated word problem. We're going to look at limo service and kind of how to maximize some revenue there. And then the other thing we're going to do is some more simple problems like this. All right, have a great night. See you guys tomorrow.